Yeah, good afternoon, students. Today I am going to discuss about what is energy balance. It consists of two types. One is steady state and the other one is unsteady state. So first of all, what is meant by a steady state? A steady state means if any process which doesn't depend on time, that is called a steady state. If any process which depends on the time, that is called unsteady state. So based on the steady state and steady state, we can write here what is the energy balance. The energy balance it can be written as the energy in minus energy out plus energy production is equal to energy accumulation. So this is the entire energy balance we can apply for any system. So if you take energy in and energy out and energy, is there any production in that system, it should be equal to the energy accumulation. So first of all, we have to know what is the energy in, how the energy entering into the system, that is the main question. So here the energy entering into any system, if you take any system, the energy may enter into the system in two ways. One is due to conductive transport and the second one is the convective transport. So what is meant by conductive transfer? Suppose if you take an example of conduction. So the mode of heat transfer here takes place by collisions between the molecules, adjacent molecules in that object. So that is called conduction. If you take the convective transport, so there will be a change in phase, either liquid to gas or gas to solid or solid to liquid. So if the heat transfer takes place from one phase to the other, that is called convection. If the heat transfer takes place within that object, that is called conduction. So here the rate of energy entering into the system in two ways, by conductive transport and the convective transport. Similarly, the rate of energy out from that system in two ways. One is conductive transport, second one is the convective transport. The third term is energy production. You need to calculate the how much energy is produced in that system. If you take any system, you need to calculate the how much energy is producing in that system. So after that, you need to calculate the how much amount of energy is accumulated in that system. So this is the overall entire energy balance equation. So if you observe the units of energy, so what are the energy units? So generally the energy units are joules or calories or BTUs. If you write the energy balance equation in terms of units, so energy in, we will write generally it is denoted as rate of energy in, rate of energy per time. Rate means energy per time. So the rate units are and joules, and the time units are joules per second. So the whole unit of the energy in is rate of energy in joules per second. Similarly, the whole unit of the rate of energy out is joules per second. Similarly, the rate of energy production should be also the same. So how will you calculate the rate of energy in? This is the question. So how will you calculate? You take any system. So how will you calculate the how much amount of energy entering into that system? So that is the question. So suppose if you take any slab material, you are supplying some amount of heat to that object. Let the inlet temperature of that fluid is, let's say, Ti, and the outlet temperature which is coming out from that substance is T0, and the heat flow rate is, initial flow rate is Q1 and final flow rate is Q2, and you know the mass of that substance is M, and you know the specific heat of that substance is, let's say, Cp. So now you have to calculate the how much amount of energy transferred through that substance. So according to we know that the Q is equal to rate of heat transfer equal to, you can write mCp delta T. So where M is the mass rate of your fluid, how much at what rate that fluid is flowing through that substance, into, and its units are kg per second. And similarly, what is the heat capacity of your substance or fluid? Depends on the fluid, and its units are joule per kg Kelvin. And you know the temperature, you know very well about the temperature units are delta T. Kelvins, Fahrenheits are Rankins. So if you take Kelvins, the units, if you cancel all the terms, the final unit will be you will get joules. We cancel the Kelvin, kg. So joule per second. This is the rate of energy entering into the system. So in this way you can calculate the rate of energy into the system, joule per second, or we can call it as watt also sometimes. It is denoted with watt, W sometimes. So in this way you can calculate the rate of energy entering into the system. Similarly, at the same time, you just calculate the how much amount of energy entering into the system by the help of convective transport. That is, in that you have to use the Newton's law of cooling. So what is the Newton's law of cooling? The rate of heat transfer the rate of heat transfer which is directly proportional to the temperature drop. If you remove the proportionality constant, we can put it as heat transfer coefficient, that is H into delta T. So if you remove the proportionality constant, instead of proportionality constant, just put the proportionality constant is where is delta T and H. So where H is called the heat transfer coefficient. Thanks. Voice increase.